Limitations of an op-amp. In this course, we can only solve circuits with linear elements. Op-amps are also linear by this observation. Suppose we have a voltage-controlled voltage source with V out equals to 4 Vx. So in other words, I'm going to have an op-amp that looks, I'm going to have a voltage-controlled voltage source, an op-amp, that's going to look something like this. Now, I call this Vx. I should have called that Vin. So if I look at this, I'm going to have some output, and I'm going to have 4 Vin. So if I now plot this thing, what we're going to show here is that if I plot V out versus V in, if I look at this thing, I should have a linear line where I look at this thing and I look at the slope, and the slope in this case has to be the gain, and the gain in this case is going to be 4. So in other words, the plot of V out versus V in shows a linear behavior. So then it begs the question, under what conditions does the op-amp behave linear? When does the op-amp behave linear? It turns out that the op-amp must satisfy 3 conditions. And these are the voltage saturation. The third is current saturation. And then finally, there's a third one that's called the slew rate. And a lot of the times the slew rate is labeled SR. So we want to look at each of these individual things to get a sense of what happens. So the first one I want to talk about is I want to talk about voltage saturation. So what do I mean by voltage saturation? What does voltage saturation mean in terms of the op amp? It is the point beyond which the op amp cannot amplify the input signal slash voltage. In other words, the output is already amplified to the fullest voltage limit. We've already said this, and we should say it again, that the maximum voltage of an op amp are the supply source values of plus or minus 15 volts. When the output voltage exceeds, right? So this is the important. So when it exceeds its possible value, the op amp is said to be saturated. And it outputs its max value of plus or minus 15 volts, the value of these power supplies. So there's a language here. So the plus or minus 15 supply voltages are often called the rails. And you'll see what we mean by that when we draw it out right now. So if the op amp has an output voltage of less than plus or minus 15 volts, it behaves linearly, where V out, which is the gain times its input has the V out less than the supply voltages. And in this case, it's 15 or negative 15. If it's more than the supply voltage, it saturates to the rail values. So in this case, that tells me that then if you try to take an output greater than the supply, then it always rails at that. It's the graph that's most important. So graphically, it looks like this. So I'm going to set up my axis. So let's see, let's make it nice and large. So I'm going to bring this down one more, and then I'm going to have that up here. This is going to be my positive 15 volts, and this is the output. And then, of course, this here is the input. And then down below, I'm going to have my minus 15 volts, and it's going to look something like this. So if I have a gain where it behaves linearly, then I'm going to go like this here. But as soon as I try to exceed it, it flattens out. So what do we say? That at this point right here, this is the linear behavior of the op amp. So when I'm looking at this, we say if it's in here, then it's linear. But if you try to exceed it, we then says it rails at positive 15 volts. Again, when I look at here, and what I'm showing here is that if I'm linear, if I stay below negative 15 again, then I have linear behavior again. But if I try to exceed it, then we say that it rails at negative 15 volts. So that's what we mean when this happens here. And I think that graph is pretty important. So as an example here, if an op amp has a gain of 1,000 and the supply voltages are plus or minus 15 volts. If the input voltage is below, let's say, 15 millivolts, the amplifier, the op amp, will amplify linearly. However, if the input um, changes to, let's say, 20 millivolts, the output will not rise to 20 volts, but only to 15 volts. This is the saturation point. Beyond which it cannot be able to further amplify. So number wise, we're saying like this. So if I have my output, and this is equal to, let's say that this is a gain of 1,000 times my input. So if that input, let's say, is 10 millivolts, which is less than 15. So when I put this in, you're going to see that this amplification is then going to be 10 volts, which is less than the supply voltage of positive 15 volts. I have a linear op-amp. However, if I take my output and I now change my input so that V input is now 20 millivolts, you're going to find that this guy is going to try to exceed it to 20 volts. But you're going to find that this thing rails at 15 because it has to be the maximum that it could be is this supply voltage, which is, of course, plus 15 volts. It will not go to 20 volts.